Good morning, everyone. Today we are going to continue the concept of a function, part 2, and this will be sketching graphs. So basically just looking at key components of graphs. And again, this should be review. So there are several important key features of the graph, y equals f of x, that you need to be able to identify. The first one being intercepts, the points where you cross the x and y axis. Also recognizing intercepts are also called roots. X-intercepts are called roots. Sometimes you see them called zeros. Okay? You should recognize those terms. Vertices, or the vertex, are points where the graph reaches a maximum or minimum point. So here we have a maximum. Here we have a minimum. We talked a little bit about that in the last lesson. Asymptotes. You might remember asymptotes are lines that the graph tends to follow or travel along. All right, so we have a vertical asymptote right here with the equation x equals c, and we have a horizontal asymptote here with the equation y equals d. Asymptotes are always equations of lines. And you may remember that from our unit that we did with rational functions. All right, and then the final thing we have are symmetries. All right, and finding a line of symmetry. Also sometimes called the axis of symmetry. It is the point at which you can divide your function into two equal parts or two very symmetric parts. All right, so use technology to sketch this function, labeling all axis, intercepts, and asymptotes. All right, so I went ahead and put some of these into Desmos already. And if we look at this graph, here you go. We got the whole thing right here. We should have a vertical asymptote at x equals -4, and we should have a horizontal asymptote at y equals 1. So that's what our graph looks like. And we're going to come back, and I'm just going to kind of sketch that in here for you. And remembering from our section on rational functions, x equals -4, and then y equals 1. Those are our asymptotes, okay? And then we actually have if you go back to the graph, we have a x-intercept at 3, 0, and we have a y-intercept at 0, and it's like -0.75. So it looks like this. So we have an x-intercept at 3, 0, and a y-intercept at 0, -0.75. And we can get that from our graph. Here's our 3, 0, and 0, -0.75. So it goes ahead and shows those if you use Desmos. All right, and then, our graph looks something like this. Then we have this piece up here. Okay, so we've got our asymptotes labeled, we've got our intercepts labeled, and here they are. So we labeled everything we needed to label. All right, find the minimum value of f of x equals x e to the x. All right, so if we graph that in Desmos, I went ahead and put these in. We'll look at this graph, and this is what it looks like. And we are literally just looking for that minimum value right there. It is the lowest point on the graph. So the minimum value is -0.368. All right, so the minimum value is -3.68, and then the range, of course, has to be anything greater than that. So the range is y is greater than or equal to -0.368, because everything in our graph is above that minimum point. All right, hopefully that makes sense. All right, continuing on. Find the coordinates of the vertices on the graph for this function here. And given that the curve y equals f of x has a line of symmetry, find its equation. All right, so again, went ahead and put this in Desmos so we could look at it. This is what it looks like. You can see that the line of symmetry is going to be at x equals 1 because that is where this graph would fold in half. Like a hot dog? A hamburger? I always get confused. I think that's a hot dog. But you guys see what I'm saying. If we looked at the line x equals 1, that would be a mirror image on each side. And then you can find these minimum values just by touching on the points and the maximum values. And I do believe that that is what we were looking for. We have 2 minimum values or vertices, 1 maximum value. So those 3 things are vertices, and then we have a line of symmetry. So this entire lesson is just about putting things in your calculator and being able to see what comes up. So we have vertices at 1, 0, negative 0.414, comma, negative 4, and 2.414, negative 4. And then we have I'm going to just call it an axis of symmetry, or a line of, I guess it's a line of symmetry since it's not on an axis, but x equals 1 is our line of symmetry. Call it the line of symmetry. All right, so literally just plugging things into Desmos or our calculator. All right, so here we're going to work backwards and see kind of what we have. So in this, we need to sketch a graph with the following properties. So we have a range that is less than or equal to 0. So that means anything down here below that line. And then we have or greater than 1. So up here. So we have this space in the middle, and hopefully, you know, if I drew it a little more clearly, you could see it. But yes, so we have above 1 and below 0, okay? We have vertical asymptotes at negative 2 and 2. So we're just going to go ahead and put this in here. Draw those in. And I'm going to leave this because we're not touching this, because it says the range is above that, not equal to, so just above it, and then we are below 0. So this I'm going to actually put in like that, because this is this part. We are less than or equal to 0. Okay, and then the only axis intercept is the origin, which is also a vertex. So that means that we need to follow these asymptotes. And we have that. And then we know that we have something up here because of our range. It tells us that we have something up here due to our range. So that is a possible graph. Pretty straightforward. Just take each step, one step at a time, and see what you can figure out. All right. Solving equations using graphs. Instead of being asked to solve an equation, you might instead be asked to find the roots, same thing as solutions or x-intercept, or the zeros. Okay, those are all the same thing. Find the zeros of this function using your calculator. So again, I put that in Desmos somewhere. Here it is. And that is what it looks like. So hopefully, what do we have? This is where we might need to use a graphing calculator and use the minimum value. Might be a little more helpful. We are looking for the places at which we cross the x-axis, so we're looking for those zeros. Is that the only thing are we looking for a minimum? I have to go back to the question. Oh, we're just looking for the zeros. Okay, so we have a minimum, but we're just looking for the zeros. So we have 0.45 and 3.63. All right, that's it. So where do I cross the x-axis? And that would be at 0.450, comma 0 and 3.63, comma 0. That's all we're looking for. Again, just using technology. Okay. Lastly, find the